Number 6. So here, we're being asked, given the following equation. Notice it's already balanced for us. And if you doubt me, go through and check how many nitrogens and how many hydrogens are on both sides of the reaction arrow. All right? No need to trust me. Check it out for yourself. It's good practice. A, determine to 1 decimal place. And so the question is giving me a very specific thing to follow. 1 decimal place. Determine to 1 decimal place the molar mass of each substance and express each mass in grams per mole. Well, that's the unit for molar mass. So awesome. Now, we will need a periodic table. I don't expect you to do this off the top of your head. I never will. You will always have access to this periodic table, so use it. So we have 3 substances. We have N2, right? And so that is going to be 2 of these nitrogens. Now, we're only going to 1 decimal place. So, if you don't believe me, I can show you my work here. 14.007 times 2. If I'm going to be reporting my answer with only 1 decimal place, I'm going to have to go with 28.0 because that 1/4 isn't large enough to actually affect the 10th place. So, got 28 grams per mole. Next up, hydrogen, right there. Clear that up. Now, it's H2. There are 2 of them. Again, 1 decimal place. The 100th place is not large enough to make me roll this spot up, so I'm going to go with 2.0 grams per mole for H2. So I've accounted for nitrogen, I've accounted for hydrogen, and by the way, notice this is 3 H2s. You might think, well, don't I need to multiply this 2.0? Don't I need to multiply that by 3? No, because I'm not being asked to do anything with this balanced chemical equation yet. I'm simply calculating the molar mass of each substance. It is true that according to this reaction, we need 3 times as much hydrogen as we need nitrogen, but the molar mass of H2 is always the same, 2.0 grams per mole. And lastly, we have our ammonia, or NH3. Let's calculate the mass of that. So we have 3 hydrogens there. So I'll multiply that by 3. That's the mass due to hydrogen, but there is that 1 nitrogen. So let's look at our nitrogen. So answer plus 14.007. Again, we're only going to 1 decimal place, and so that 3 isn't enough to get me to roll over into the 10 spot, so I'm going to go 17.0 grams per mole. All right, I think that's all we need our periodic table for on this particular problem. Let's move on to B. There are 6 different mole ratios in this system, right? This is referred to as a system, right? This balanced chemical equation. Write out each one. Now I have this ratio of 1 mole N2 to 3 moles H2. I have this ratio of N2 to ammonia, so I have a 1 mole N2 to, what's that, 2 moles NH3. And now the only relationship I have left is this hydrogen to ammonia relationship. So I'll go 3 moles H2 to 2 moles NH3. Well, those are the only 3 relationships I have up here in this system, but this question is asking for 6 different mole ratios. Remember, I've written 1 to 3. I also have the relationship of 3 to 1, right? And that's important for you to remember when you're looking to generate your conversion factors. You can list any species as a numerator or a denominator at any time. You can flip these things back and forth. And that's going to be very important when you're trying to match units and get them to cancel using the factor label method of dimensional analysis. So our last 3 are actually going to be these same ratios but flipped. So 3 moles H2 to 1 mole N2. 2 moles of NH3 to 1 mole N2. And lastly, 2 moles of NH3 to 3 moles